What will you do if the quadratic equation is not factorable? Can you think of other methods to solve for the zeros of that quadratic equation? Let us consider this example: x squared plus 4x minus 7 is equal to 0. This quadratic equation is not factorable because we can think of factors of negative 7 that will give you a sum of 4. So this quadratic equation cannot be solved using factoring. By completing the square, we can solve for the zeros or the x-intercepts of a quadratic function. So the first step is to isolate the variables on the left side and the constant, negative 7, we're moving on to the right side, which becomes now positive 7. Now, this method is called completing the square because we need to add something here to make it a perfect square or a Ph.D. But to maintain the balance of this equation, whatever we add on the left side, we also need to add it here to the right side. So to figure out what's the number to be added on both sides of the equation, two things. First, you need to get half of the b value, or the b over a value, which is the coefficient of x. So half of 4 is 2, and then square it. Again, half of 4 is 2, square it is 4, which means we need to add 4 to both sides of the equation. Now, since the left side is a perfect square trinomial, x squared plus 4x plus 4 can be factored out as x plus 2 to the second power. Right side can be simplified as 11. Doing the inverse operation, since we have here the square, that means we need to get the square root of both sides. So when you get the square root of both sides, we now have x plus 2 is equal to root 11. Now, if you're going to get the square root of both sides, this means this can be positive or negative, and you will get this answer 11. So for example, if we have x squared is equal to 25, then x can be positive 5 or x can be negative 5. So the same reasoning for this problem, if we get the square root of both sides, we now have x plus 2 is equal to positive root 11 or negative root 11. And solving for x by itself, we can subtract 2 to both sides. And the two values of x now will be x is equal to negative 2 plus root 11. And the other one is x is equal to negative 2 minus root 11. And using your calculator, you can round off this answer to 2 decimal places. So if we plug in negative 2 plus root 11, that will give us an answer of approximately 1.32. And for the second root, we have negative 2 minus root 11. That will give us negative 5.32. So the zeros of these quadratic equations are 1.32 and negative 5.32. Now let's take a look at example number 2. 2x squared minus 16x minus 18 is equal to 0. So in this problem, there is an a value of 2. So the first thing that we need to do is to divide every term by that 2. And when you divide each term by 2, this becomes now x squared minus 8x minus 9 is equal to 0. Next, we need to isolate the variables on the left side. That means we need to transfer negative 9 to the right, and that turns now to positive 9. To complete the square, try to recall what we did with the example 1. First is we need to get half of negative 8, which is negative 4. And then square negative 4, that's 16. So we need to add 16 to both left and right side of the equation to maintain the equality. Left side is always a perfect square trinomial. So this can be factored out as x minus 4 to the second power. Right side is 25. After this, the inverse operation for the square is square root. So we can get the square root to both sides. You may or you may not write the square root, but make sure when you get the square root to both sides, make sure you put plus or minus 5. Because this can be positive 5 or negative 5 to make the answer equal to 25 when you square it. So the values of x now are, if I add 4 to both sides, I will have x is equal to 4 plus 5, and the other x value would be 4 take away 5. So the two values for x would be 9 and negative 1. So the zeros of this quadratic equation would be 9 and negative 1. And you can always check your answer. When you plug in 9 to the x values, you should get 0 on the right side. Same thing with negative 1. When you substitute negative 1 to all the values of x, the equation should be true. This example number 3, we have 3x squared plus 12x minus 9. Again, what's the first step? We're dividing everything by that a value, so we need to divide everything by 3. So when you divide this by 3, each of them, I will make it now x squared plus 4x, this is minus 3, is equal to 0. And now we have x squared plus 4x is equal to positive 3. So I transpose negative 3 to the right side, so that turns to positive 3. What are we adding to both sides to make it a Ph.D? Yes, it is 4. Because we need to get half of 4, that's 2. Square it is 4. So we need to add 4 to the left and also to the right side to maintain equality. And since this is a Ph.D, left side is always a perfect square trinomial. So you can factor it as x plus 2 to the second power, and the right side is 7. Again, the next step, you take the square root of both sides, and that gives us x plus 2 is equal to 7, root 7, and again we need to have plus or minus. Which means our first value, if you subtract 2 to both sides, that will be negative 2 plus root 7. And the other one is negative 2 minus root 7. And again, just plug it into your calculator. So we have negative 2 plus root 7. That gives us 0.65. And the second is negative 2 minus root 7. That will give us negative 4.65. So the two zeros of these quadratic equations are 0.65 and negative 4.65. Example number 4 is more challenging because this involves fraction when we do completing the square. Remember, to determine what to add to both sides of the equation, again we need to get half of 7, which is 7 over 2, and then we square it. So that becomes, we need to add 49 over 4, and here 49 over 4. Again, we need to get half of 7, which is 7 over 2. And then you square 7 over 2, that makes it 49 over 4. So we now have x squared plus 7x plus 49 over 4, which is also a perfect square trinomial. And that can be factored out as x plus 7 over 2 to the second power. The right side, 18 plus 49 over 4. This means this has an LCD of 4. And you have 4 times 18 is 72. 72 plus 49, that gives us 121. So 18 plus 49 over 4 is the same thing as 129 over 4. One tip is when you're simplifying the right side, it's always good to have it as an improper fraction. That way you can easily get the square root of your numerator and the square root of your denominator. So the next step here is to get the square root of both sides. And when we get the square root of both sides, that becomes x plus 7 over 2. What's the square root of 121 over 4? 11 over 2. You simply get the square root of 121, which is 11. You get the square root of 2, which is now plus or minus. Again, don't forget, there's always positive and negative for the square root of that number. Solving for the two x values, we now have x is equal to negative 7 over 2 plus 11 over 2. And the other one is negative 7 over 2 minus 11 over 2. And simplify both values for x. So the first one becomes 4 over 2, where the value of x is 2. And the second is negative 18 over 2, which is equal to 9. So the zeros of this quadratic function is equal to 2 and negative 9. Now let's have our example number 5. X squared minus 14x plus 50 is equal to 0. So again, the first step that we need to do is to always isolate the x on the left and the constant on the right side. So now we have x squared minus 14x is equal to negative 50. Be careful because the common mistake is when you transfer the constant to the right side, make sure you change the sign. You have minus 50 on the right side. So, what do you think are we adding to both sides of the equation to make this a perfect square trinomial? Yes, we're adding 49 because this means we need to get half of negative 14, which is negative 7, and then we square negative 7, that's 49. So we need to add 49 to both sides of the equation to maintain equality. Left side is always a Ph.D, so this can be factored out as x minus 7 to the second power. Right side, negative 50 plus 41 is negative 1. When you get the square root of both sides, you will now have x minus 7 is equal to plus or minus the root 1. Can you think of a number that when you multiply it by itself gives you a negative number? It's not possible, right? It's either both are negative or both positives will give you a positive answer. So square root of negative numbers are imaginary numbers, which means that the values of x, you could write it as 7 plus or minus root negative 1. Or also, you can write x is equal to 7 plus or minus root I when you get to Algebra 2. Which means that there is no real solution. Meaning, there is no value of x that will make this quadratic equation on the left side equal to 0. What does it mean when you graph the quadratic function? When you graph the quadratic function, this will be a parabola because a is positive 1, and that parabola is above the x-axis, which means the graph will not cross the x-axis. So there is no x-intercepts. Thank you and hope you learn completing the square.